Okay, so we are recording. Going to share my screen. Okay. So, hello everyone. Welcome to week 2 of the IEEE ACE CAD 3D printing group. Today we're going over the basics of using Inventor, loading it up, what's important on the home screen, and then at the end we're going to actually create a part as an example. So when you first load up Inventor, it's going to take you to the home screen, and this is what it looks like. You have a new tab, so you can quickly create a part, an assembly, a drawing, or a presentation, which we'll get to later, what those are. You have all your tools at the top and your ribbon, and you have your recent documents. So real quick, in the home screen at the top, you had the Tools tab, and this is your Tools ribbon. The two probably most important pieces here are your application options, which you can also access once you're inside a file, but you can do it right from here. This is how you change the default settings for Inventor as a whole, which again, when we go into Inventor later, I'll show you. And then also customize, where you can edit ribbons. You can do, I'm sorry, this is the application settings. These are all the different tabs underneath it. And then underneath the customize tab, you can edit your ribbons inside. So if you want to have application settings in a more easily accessible area, you can do that from the Customize tab. You can add your own keyboard shortcuts or what's called a marking menu, which is when you're inside a file or a model, you can, that's like where you have like quick options, which again, I'll show you later. So then we have the Get Started. So the Get Started ribbon and the Quick Access toolbar. So the Quick Access toolbar is above up here. That is always there, and it has this home icon. So no matter how many files you have open, you can always just click this home tab and it'll bring you back to that home screen. Obviously, the most important tabs on the Get Started are your new and open tabs. So you can start a new project or open up another project. And real quick, I want to note that it does have a tutorial gallery, but when you scroll through the tutorial gallery, you'll notice that it's rather situational, and if you have a specific problem, you're better off going to like an Autodesk like knowledge website. But if you ever just want to scroll through the tutorial gallery and see like different tools, tips, or tricks, that's definitely a good place for it. But again, a specific problem, that's probably not the best place to go. So the home screen, you have projects and shortcuts. The default project is the one that's normally selected for you. Projects contain workshops and libraries, and they're most useful for companies or firms because with the libraries, they hold standard models and files that would be commonly used amongst all of your employees. So if like one company for an entire assembly, they use like 3 specific types of nuts and bolts, those models would be in the library so that all of their employees can just access those models. But for what we're doing, we don't need to do any of that. You're just going to use the default project. A little side useful thing is the shortcuts. So you can add a shortcut to certain folders in your file explorer. You can add shortcuts to certain links if you want to always have access to like a certain tutorial page or a certain like tips page. So that's the projects and shortcuts section of the home screen, which is on the right side. So on the home screen, you also have different types of files. So if you click that new tab, you can press new and it brings you to this window, or you just have the new section. So when you create a part, it is a 2D, 3D object, a single object, and you can create a standard one, which is object composed of features. Oh, did not mean to do that. Composed of features and one or more bodies. So that's creating a single piece. Or you can even create specifically something that would be made out of sheet metal, which it's made to be bent and unbent. Then you have assembly, which is you take your parts that you created individually and you put them together. And that can be a standard, so you just take your standard parts and put them together, or you can do a weldment, which could be taking different sheet metal parts or standard parts in a way that they're meant to be welded together. So that's a useful thing right there. Then you have your drawings. So it's create an annotated document. If you have ever seen a data sheet for a certain piece, model, part, whatever, this is part of that data sheet. It'll have different views of it. It would have all the dimensions labeled so you know what you're buying and how big it is, whatever. And then you have a presentation, which is kind of like a drawing, but for full assemblies. So drawings apply to parts and presentations apply to assemblies. And whenever you click one of these tabs, like if you just click part, it'll automatically create a standard part. But then once you're inside the standard part, you can convert it to sheet metal. So that's if you click assembly, you create a standard assembly. So if you want to create a part, so on this screen, if you create just new part, it'll take you into here. So real quick, I'm going to run you through the tools tab. Two important things. You have your document settings, which is where you can go to edit your units, snap spacing on your planes, or certain grid options for your planes. And then you can also change the material appearance of your model. That's just something more so aesthetic, or if later you want to do different stress testing, but that will be much later. Don't have to worry about that right now. You can do that in Inventor. So now creating a part, you can do sketching. So drawing a 2D sketch and extruding it in some way is the best thing about Inventor. So under the sketch tab, you have the option to start a 2D sketch. So if you have nothing in your workspace and you press start a 2D sketch, this 3D coordinate plane will show up. And you'll also have this little box up here. It's hard to read, but this face over here says front, right, and top. So this shows you a better representation of what this represents, because besides, if you didn't have this, all you see was an XZ, XY, and YZ plane, which doesn't help that much in the grand scheme of things. So then you would just pick the appropriate plane. You would just click on whatever plane you want, and you would start drawing in that plane, which again, we'll do later with the example. So after you select your plane, the full ribbon will become available. If you notice here, a lot of it is grayed out. You only have to create or draw sketch. All of this is grayed out. But once you select your plane, it'll all become available to you. So again, these are just the different sections. So you create new entities, modify, you can manipulate those entities. You have a pattern, so you can copy and quote unquote copy and paste them in different geometries. Constraints are something that might be a little different to some people. You can force certain relationships between entities. So if you want two like free drawn lines, if you take two lines and just free draw them, but you want them to be parallel, you would like use the parallel constraint, which is right here. It would force them to be parallel. You have perpendicular, tangent. So that's how constraints work. And one thing nice about Inventor is if you don't know how to use a tool exactly, just by hovering over it, it'll give a short example. And if you keep your mouse there, it'll then drop down even further and show you a visual of how the function works. So you're not just thrown out there and expected to learn it. And if you don't know, you got to go on Google. You can just learn it from the visual. So after you draw your 2D sketch, then we have our 3D tools. So you have all these different types of extrusions. So you have normal extrude, revolve, a sweep, loft, coil. Then you can also do emboss and decal, which is just taking a picture and slapping it on your model. And it's the same thing as a 2D sketch. You have your create, which helps create entities, modify, which manipulates them. Something very important here is your work features, which is your plane, which is very nice because you can create your own custom planes. So like in the beginning, we just had the X, Y, XZ, and YZ planes. But after a while, you might need to make a custom plane in order to create like an angled part or an angled like piece of your part. They also have surface. So the surface tools on the end over here are very similar to the modify tools, except the modify tools affect the solid, whereas the surface tools strictly affect the faces of your object. And I know I'm going very fast through this, but again, once you're in Inventor, any of these tools that you want to learn more about, you can just hover over it and it'll tell you. So we are going to do an example because, again, for the sake of brevity and sanity, I'm not going to list every single tool. But again, if you have Inventor installed, you can go in and just start messing around with tools, start messing around with all the different sketching and extruding. So again, at this point, you can just watch through WebEx. You can follow along and do it with me, or if you feel confident, you can just skip ahead. So what we're going to be making is this fixture block. So I'm going to then move this out of the way. And I have Inventor open. You guys can see Inventor, right? When I just moved that, I had it set to my screen, not just Google Chrome.
Yep.
Okay, awesome. Okay, so the fixture block is just a part. It's not an assembly. It's not a bunch of parts put together. We can make a drawing of it, but it's definitely not a presentation. So as you can see here, I already made one. This has all my recent documents. But real quick, we're just going to press part. And it's going to load a little bit. And it loads you in. So here, again, we have the workspace and we have all our tools up here. Before we even begin, it's important to note that if we look at the drawing, right here, it says all dimensions are in millimeters. By default, the default unit for Inventor is inches. So to change that, we would go to Tools. We go to Document Settings. So here again, we have Application Settings, which I mentioned before, which I'll just go into now to show you. It's all the general settings for Inventor. So you have a notebook. You can change your save settings. You can save the file. You can change file settings, colors. You can even change your display. You can change certain things about parts, certain things about sketches. So these are just the general application options of Inventor. But we just want to change the specific units for this document. So we're going to go to Document Settings. Here we have a whole bunch of subcategories. So we want to change units. The default units for length is inch. Someone's waiting in the lobby. Sorry, 1 second. Am I going to have to stop sharing to do that? Okay. Real quick, I have to stop sharing because I have to let someone in and it wasn't letting me do it while I was sharing. Where'd this person go? All right, well, it's not gonna let me see them now, I guess. So, all right, sorry, we're back. So again, our units, we're gonna change this to millimeters, but you can also change your angle from degrees to radians, time, seconds to minutes, mass, from pound mass, gram, kilogram. So now we just want to change length to millimeters. So we're gonna apply and close. So now our default is inches. So first thing we want to do is look at our drawing here. Is we want to create our base. So looking at this from the top and just the shape in general, probably the best thing to do first is just to create a rectangle. So we're just going to start with our 2D rectangle. So we're going to go to Sketch. We're going to start a 2D sketch. And so here's the 3D coordinate grid. So we see that the front is facing, I guess, this way in the Z direction. The right is facing the X direction and top is facing the Y direction. So again, based on this drawing, we want to work probably in the XZ plane so that our top is facing upwards in the XZ plane. So we're going to just select the XZ plane. It's going to bring us to here. And in the top here, you'll see that it's like rotated weirdly. So our front is actually over here. So I'm going to, when you hover over it, you can just rotate using these two arrows.
So, quick question.
Yes.
What you're about to draw is the base looking from the top.
Yes. So what I'm about to draw is I'm going to forget about this semicircle part for now. I'm going to
Okay.
draw from here, from where this dotted line is, to here. I'm going to make this base for the rectangle, which is going to end up
Okay.
forming this bottom part.
Okay, cool.
Yeah. So I'm going to select, so up here we have lines, circles, arcs, and rectangles. I want to create a rectangle. So you just click this. You also have all different options. You can also create slots and polygons, but we just want our 2-point rectangle for now. And you can place this anywhere in the coordinate plane. I'm just going to place it in this quadrant right here. So I'm just going to click. And now, based off our drawing, I'm just going to cancel that for a minute. Based off our drawing, our dimensions. So again, this is the top and this is the front. Oh yeah, so Kevin just dropped the link to get to this document. So I don't have to keep dragging it back and forth. Thank you for that, Kevin. So the dimensions for this are 60. Again, just for this rectangular part are 60. And then if we take 9, and this would also be 9, so 9 plus 9, 18, plus 12 would be 30. So it's 60 by 30. So if we want to create a rectangle, we just put the corner. And now what you can do is, if you can see at the top that the highlighted units, so that's going to be our width. So that's going to be 30. So we can just type in 30, and then you press tab, and notice how the units get locked. So now those units are locked at 30. I can only edit the height now. And then we're going to type in 60. And then you can just press enter, or you can hit tab again just to make sure it's locked. Everything's locked in place, and then just press enter. Now, real quick, you'll notice how these parallel lines pictures or like images are showing up. So those are our constraints. It's showing us the constraints. So if we highlight everything again, it's going to show us certain constraints. So if we hover over it, you'll see that this top line and this bottom line are forced to be parallel. That means whatever I do to this drawing, they will always be forced to be parallel. Same thing with these two side ones. And if we look down here in the corner, these two lines will be forced to be perpendicular. So the combination of all these constraints means that no matter what I do to this shape, if I try to manipulate in any way, it'll force itself to be a rectangle, a perfect rectangle. If I try to do something to it that'll violate these constraints, it'll ask me, do you want to overwrite constraints? And you can press yes or no. Like if I try to stretch, right? I want to move, and again, I'll show you, if you hover over it, stretch is selected geometry using specified points, and you can see what it does. So if I want to stretch something, I'm going to select, hold on, it's not, I'm going to select this point, and then a base point, it's just here, and I can just click and drag. And it's going to force it to be a rectangle. I can't undo that because of the constraints right now. So that's how constraints work. So next part of this is it's not a perfect rectangle. We have these little cuts into it. These little cuts, we can use the chamfer tool. So if we go here, we have fillet, which is rounded edges. But if you click this drop-down menu, we have chamfers. So it shows you what it does. So it's going to create that little cut. Now it's hard to see, but in this menu, you'll see that it shows the line, the diagonal line, and then it creates these a box with the red lines. And then you have little letter D's for distance. So this distance right here isn't the diagonal, it's the straight lines that come out of it. So again, based on our drawing, those straight lines are 9 millimeters. So we're just going to change the distance to 9. And then we're just going to click this line and this line. And there we go. We have our chamfer here and our chamfer here. And you can leave these dimensions because we can hide them later on. If you really just want to purge your document of any dimensions, you can just by clicking on them and pressing delete. I'm going to leave mine for now, but if you want to get rid of yours, you can. I'm going to get rid of this point though, because we don't, if we get rid of the point, see, so that they disappear there. But if you click dimension, press point to point, and it gives you this little nice dimension. If we want to do it again, it'll do. So Inventor realizes that you already made this measurement, so it's going to make this measurement next. It's going to, you already measured the horizontal, so it's going to measure the vertical over here. Now, we created the base of our object. So next thing we need to do is we need to extrude it to make it 3D. So next we're going to go to 3D model in the top left. And again, we have all of these special extruding types, but we don't need to create we don't need to revolve it. We don't need to sweep it along the line, which I'll show you there. We just want to extrude it, just straight up take the sketch and make it 3D. So we're just going to do that. And you'll notice that Inventor automatically knew what shape I wanted to do because we only have one sketch in our workspace. So it already knew what we wanted to do. So there's different types of extruding. In this case, we have the behavior. So we have the default, which would be, I guess, the normal direction upwards in the top direction. Then you have flipped, so it would go downwards. You have symmetric, so it splits it. And notice how it automatically does the math for you. So if you want the total width to be 10 millimeters, it automatically makes it 5 and 5. You don't need to put in 5 to go in either direction. And then you have asymmetric. So based off the asymmetric, you have your distance A, which would be the default direction, and your distance B, which would be the flip direction. So this is how you would create asymmetric extrusions. We just want to do a default. And again, based on our drawing, the width is 9 millimeters. So we're just going to make it 9. And that's it. We're going to press OK. And done. We have our first piece of our part here. I'm just going to look at it from the top right now. Or actually, I'll look at it from the isometric view. I'll look at it from this view. So next thing we want to create, looking at this, would probably just be now this upper part. Not the diagonal part yet, but this upper part. That's the next easiest thing to do. So based on that, we're going to create another 2D sketch. So when we go back to sketch, we want to start a 2D sketch. Notice how no 3D coordinate grid shows up. We have, it only lets me select certain faces and planes on the object. So we're just going to click on this top part because we want to draw on the top. And now that's our new plane. And now you can, I'm sorry I didn't mention this before, you can just freely pan around by using mouse 3. And if you want to, if you're off screen and you want to zoom back to your drawing, over here you have this magnifying glass with a sheet. You just click it and it brings you back. So what we want to draw here is we want to draw this. So again, our rectangle before only went up to 60. So first thing we want to draw is another rectangle that is 18 wide and then again by 30. Yeah, sorry, mouse 3 is clicking the mouse wheel. Thank you, Kevin. So we want to create a rectangle that's 18 by 30. So I'm just going to, we already have this as our drawing plane. We're going to click in the corner here. We want that bottom dimension to be 30. Again, you just type it in and hit tab, and then 18, tab. This creates our rectangle. Enter. And then we want to create now our semicircle part of this. Now you could create a circle and then trim it. I can show you that as well. So if we want to create a circle and trim it, you would want to click the center point and go to the end point just to show you how to use certain tools. Then you would go to trim. And if we hover over trim, it tells you how it works. Trims a curve to the nearest intersecting curves. So if we select trim and go here, you'll notice how half of it based on the intersection becomes dotted and the other half stays solid. So the dotted part is what's going to get cut off or like disappear. So we want this bottom part to get cut off. So we'll just click that, and now we just have our arc. If you wanted to do it using the arc tool instead, you would want to make a 3-point arc. And if you notice how when you hover over it, you might not know the order of points. It tells you. So you want to, it says right here, you want to select both endpoints first and then your arc distance. So we want to select one endpoint, and now you can manually try to find your radius, or you could just type in 15 millimeters, which it tells you in the drawing. And then just press enter. And there we go, we have our arc again. So there's two different ways to do that. So now we have our drawing here. You could create another circle here to force the drill hole, but I'm going to use the hole tool later just to show you how that works. So now what we want to do is we want to extrude this part. So we're going to press extrude again. And now notice how we have two separate pieces, so it doesn't know by default which one to use. So we have to select our profiles. So we're going to select this face, this enclosed space, and this enclosed space, the semicircle. So now we have our extrusion. Now you'll notice how this little hang off back here isn't covered yet. And based on the drawing, we know that it has a thickness, this overhang in the back would have a thickness of 9 millimeters and a height going upwards of 21 if we subtract 9 from 30. So we would want to do an asymmetric extrusion. So again, distance A is the one in the upwards direction, which we just said would be the 30 minus 9, which is 21. And then our distance B would be 9. So I'm just going to zoom out. So now we see that that overhang is taken care of, and it's extruding in the upwards direction 21 millimeters. Now when you have multiple pieces, you have this new option for output, or the Boolean output. So by default, it's to join them. You can cut it out. So if we were to select this one, it'll remove this whole back section. You can do the intersect. If you do the intersect, it'll only be this little rectangular section, or you can create a whole new solid. We're going to do join. We want them to be one solid piece. Then you just press OK. And now we have our one solid piece. Next up, we're going to do the drill hole. So the drill hole is no longer a 2D function. We're going to go to the 3D model because we want to manipulate or modify our 3D shape. And again, if you're off center, you can just click here and recenter it. So we're going to use the hole function. And it has all the different options for you for hole type, simple hole, clearance hole, whatever. If you want to see if you're going to be putting a screw into your into your piece. You have termination type, a certain distance into it, whether it's all the way through or to a certain intersection point. If you had another, like, say you had like a lip on here and you only wanted it to go down as deep as the lip, you can do the 2. Or if this, like, if you had an extension down here, but you only wanted it to go X deep or like to that to that point, you would use 2. And you have your direction. And then here you have your diameter. In the drawing, the diameter is 15 millimeters, so that's nice. It's already done for us. So now all that's left is for us to select the position. First thing we need to do is we need to click a face and location. So we need the face that we want to drill into first. So we have this face up here. And when I first click, it's just going to create it at a random point. That's fine for now because it's just wherever I clicked. Where we want this to go is we want it to be at has the same center point as this arc. So then you would just go over to the arc and it would center it at the same point. And you would just press OK. And now we have our drill hole through the object. And what I just did was, so you can pan using the mouse, but if you want to rotate your object in a more free-form way instead of using these set directions, you click the little like gyrosphere here and you can just move it around. Okay. And if you want to manipulate it, again, the arrows, you can click on it at certain angles. So now the final part that we need to do is this angled piece. Now there could be other ways to do it, but the way I'm going to show you is because I want to show you how to create your own custom work planes. So when we first created our 2D sketch, the very start, when we clicked Start Sketch, it brought up that 3D coordinate grid. Then after we created the base and we clicked Start 2D Sketch, it only let us pick from certain faces. But what happens if you don't have a face to use? We need to create your own plane then. So if we go to 3D Model and we go to the Work Features, this Plane tab, this drop-down menu, you can create all different types of work planes. What we want to do is we want to create a 3-point plane because from our math classes, probably we've learned that 1 point is a point, 2 points is a line, and 3 points is a plane. So we're going to select the 3-point plane. Since we want it to be in this center region, I'm going to click here, the midpoint down here, it automatically snaps to it. The midpoint over here, again, automatically snaps to it, and up here. And just like that, we have our work plane. Now we're going to use our 2D sketch. So we want to start 2D sketch. And again, you can click on all these other faces. And probably using this face could work because it is parallel to this plane. But again, I just want to show you how to create your own planes. So using work plane 1, which is also now in this list over here, you can just click, and now this is our work plane. Just for the sake of visuals, I'm going to go back to the isometric view, but you could do it in the side view. So the easiest way to get to this isometric view, I should have mentioned this before, is just to go to the front view and then just press the top right corner. And it'll bring you to this nice isometric view. And then from here, we're just going to create our lines again. So we're just going to click line. We're going to go from the midpoint down here, go straight across the midpoint here, go straight up, and then create the diagonal back down to here. So now we've created our 2D version of that angled piece, right? We created the 2D version of this in our new work plane. And then from there, we're just going to extrude again. 3D model, extrude. And now this one, since we created the center line and it's even on both sides, we're not going to do asymmetric. we're going to do symmetric. And again, it tells you that this piece is 7 millimeters wide. And again, it automatically does the math for you, so you just have to put in 7. Again, the output, you can make it join, you can make it cut out, intersect, or create a whole new solid in general. We want it to join with the existing shape, and just press OK. And that's it. We've created the fixture block. And now we do have the plane just sitting here. If you have dimensions, planes, whatever, literally anything, you can just go to View. You go to View. And then you have Object Visibility. And it's just a checklist of all the things that could be visible or invisible. What we have here is a user work plane. And we're just going to uncheck that, and it disappears. You could do the origin planes, origin axis. So in that 3D coordinate grid, you can make these things disappear and appear. 2D sketches, if you had a 2D sketch just like on this surface, you can make it disappear. We don't have any right now, but if you did, you can make that disappear. So that's how you can make that disappear and reappear. And that's it for now. Did anyone have any trouble using any of the tools? No? So that is it for the example. Going back to here really quickly. So we had our example. Again, after this whole thing will be made, will be given to you. And that link that Kevin sent to that PDF I was using is this. So in that PDF, it's just examples. And I highly recommend doing them. There's only so much that we can really teach you about Inventor. I mean, I could show you the tools all day, how to do certain things, but it gets to a point where you do just have to do your own practice, do your own designs, just get creative, just hop in and start working, which is the point of the project, just to take these tools that you've learned and then also just get creative with it. So this week was just teaching you guys how to make a part. You can then take that PDF and do examples, do whatever, just to get used to the different tools and programs, learn tricks. Next week, we're going to be going over the using drawings, assemblies, and presentations. I think that is it for now. Does anyone have any big questions or little questions, whatever, about what we did today?
I have a question.
Yes.
How do you make the whole design as one solid again?
Okay, yeah, no problem. So as you extrude things, so if I, okay, so I'm going to quickly just make a 2D sketch. So I'm just going to quickly draw a rectangle just on this. So, oh, I'm sorry. Before I said something called the marking menu. When you right click and bring up this wheel, this is your marking menu. You can create a lot, like it takes all your most recent tools. Like I just created a 2-point rectangle, but I also created a line. I created a center point circle before. So it takes all of your recent tools, also maybe other tools you might need if you want to make a dimension or project geometry. And it also gives this whole drop-down menu. This is your marking menu that was said before, and you can edit this in your application or in your customized menu at the home page. So here again, from the isometric view, we have this rectangle, 3D model, extrude. So now we're in the extrude menu. Down here, the output, the Boolean, You have join, so by default, it's just going to join and make it one solid with the rest of it. But then if this was, let's just say we're going to do asymmetric and we wanted it to go in 1 millimeter. Or I should say we wanted to extrude it into it 5 millimeters, right? And we wanted to cut. Well, then when we would cut, we would press OK, and it would cut out that piece. Today, what we were making only involved joining, but that's how you would cut out pieces as well. And if we wanted to undo that and extrude, you also have just the intersection. So it'll only take that little box that we just cut out. Now that would be the only thing left. It'll get rid of everything else. But by default, it is just join. So it'll just make it part of the shape.
Thanks.
Yeah, no problem. So any other questions? Again, this part of it is a little tough because it'll be rather repetitive to just go through each tool. So it's probably better just to do examples and show you how certain tools are used and like the thought process behind them. But beyond that, it is just practice. The main point of this was just to show you the home page, which again, I'm going to show you. Down here, you also have the home, or you could just click it up here in the quick access bar, and it just takes you back here. And you also have your part on this toolbar down here. It was just to get you guys comfortable with the home screen, what each part of it means, where to find certain options. That was the point of today, and then also do a quick example. This is the customize menu, by the way. I couldn't fit a picture of it in the slideshow, but you can customize all your ribbons. So if you want to take a command from any of these toolbars, you have all of your part toolbars, you have all of your assembly toolbars, drawing toolbars. You have all these toolbars, you can just grab tools from them. So from the part, we have sketch tab. So if you want to look at the sketch tab, well, you have all these pieces. You have all the arc options. You have auto dimensions, all the center points. You scroll down, you'll have all the line options. And then you can take it, you choose commands from here, and you move them over here. So if you want to take your you know, where was it? The draw line. If you want to take line, specifically draw line, and you just want to put it into your 3D, I'm sorry, your 3D model tab, you can do that. So I'm going to take line, move it here, and then press apply and close. So now if I were to go into here, it's here at the end, user commands. And it is just right here for line. So I can just create a line now on this. So there's a whole bunch of little tips and tricks, again, that we could go through. But yeah, that's the gist of it for now. I highly recommend going through that PDF, whether you actually do any of them. If you just look at them and just like talk to yourself how you would do them, that could work too. But again, there's only so much that we can explicitly show you without going through each and every tool. Especially when the tools give you, like tell you what they do, it could become very repetitive. So does anyone else have any questions? And another piece, this side bar over here, it tells you everything you've made. So extrusion 1 was that first little rectangle, it's outlined. Then we have extrusion 2, which was the upper part. Then we created the hole. Then we made our work plane, which is invisible right now, but it's there. then extrusion 3, which was the diagonal, and extrusion 4, which we just created this little box. And if we want to get rid of that, we can just right click, and there was a delete here. Oh, we have to delete the sketch, I think. I don't know. I don't know why that's not letting me undo that, but that is the case here. I don't know where my chat went for WebEx, but I'm going to stop sharing just so I can see the chat easier. Okay, does anyone else have any questions? Real quick. No? Okay, real quick. Just because this is the first time we're doing it, can you guys, if you have any immediate feedback right now about in general, like what you wanted, like what you expected to learn and how maybe we can do it better? This is the first time we're doing these sorts of things, so we want to make it work for everyone. If you have any feedback at all, that'd be great. If you want to drop it in the chat, or when we send the email, you can just respond to the email. If anyone wants to unmute or type in the chat. This was good. Okay. You guys don't have to be nice, by the way. Like if it didn't work at all, just say it. Again, this is the first time we're doing it. We want to make sure it works. Yeah, the Mechis better watch out. Yeah, and that is the one thing, like, I'm assuming a lot of us here are the vast majority ECE, but one thing you have to keep in mind when you're working on projects with multiple disciplines is whatever you design, even if we just design the circuitry, you have to realize that's going to go inside something. So even just having the basic knowledge of like what goes into CAD and designing certain things, it could help your design because you can understand like, hey, I can't wire this way because the enclosure for it would be too complicated or too bulky. It won't fit in the space it's supposed to. Just things like that. So just having general background in CAD is good. And then later in the semester, we are going to do AutoCAD electrical for wiring diagrams or wiring circuits. It would be kind of like multi-sim, but strictly like document based, not actually simulating it. But that's later. All right. Thanks guys for the feedback. So that is it for today. Again, next week we're going to go into assemblies, drawings, and presentations, and show you the general idea of how those work. So if you want to, you can create your own parts, whether it's from that PDF or if you want to do what I did, I literally just made the fixture block and then I made my own quote unquote hex screw. And during the assembly, I'm just going to show you how to like put these together. I might make another piece. So if you want to just make your own parts and have your own assembly ready to go, and then we can show you how to put it together. So that's what we'll be doing next week. Again, if you don't have the time, completely understand. If you just want to sit back and watch how it's done, that's also fine. I understand that could be rather time consuming while learning a new CAD program, but whatever works for you guys, we want to make it work. All right, so that's it. Thank you everyone for coming. If anyone has any more questions, you can ask, but that's it. Awesome. See you guys.
Thanks,
Thank you,
man.
guys.
Appreciate it. Have a good one.